This is video homework for Tim Barron, Physics 350, Chapter 2, Problem number 2. We're given two charges, one minus 2q, one plus 4q, and one located at minus d, the other at plus d, and we're asked to find the electric field at an arbitrary point P on the y-axis. And then we're asked to use a Taylor expansion and look at it when y is much greater than d. So looking at the diagram, we can see that if we were to add the components, this is going to ultimately end up going in the negative x direction and positive y direction. The diagram is labeled with the magnitude for D1, D2, and R1 prime vector, R2 prime vector, and R vector, which the components for those are listed here on the page. And we're going to end up putting all of this into the formula, which is going to give us a final answer here of q over 4 pi e naught times quantity minus 6d 2y 0 coordinates all over d squared plus y squared quantity to the 3/2. And to do the Taylor expansion, we're going to have a look at 1 over quantity d squared plus y squared to the 3/2, and we're going to pull a y to the third out of there, making it 1 over y to the third times quantity d squared over y squared plus 1 to the 3/2, and then we're going to let g equal d squared over y squared. And from there we're going to do the Taylor expansion, taking a bunch of derivatives and then adding them up using the expansion formula with the factorials below. And when we finish, you can see the answer we get at the bottom. And then when we dump the Taylor expansion in for x and y, what we ultimately end up seeing is that E vector in the x direction drops off faster than E vector in the y direction. So given the charge and distance from the y-axis, I was able to solve for the electric field using the equation listed here. Right off the bat, visualizing this with the diagram, I was able to tell that this was going to end up heading in the negative x and positive y direction. And upon completing the calculations, this was confirmed. And I also got a refresher on the Taylor expansion and the ultimate conclusion to that, in this case being that E vector in the x direction drops off faster than E vector in the y direction.